In today's machine learning video, we're going to be covering how you can build out a linear regression within Python with the help of the Scikit-Learn library. Now, this is going to be the beginning of my regression series here on the channel. We're going to start from very basic linear regressions and scale our way up before doing a final Kaggle project on it. So make sure to watch all the different videos in this series. But with that in mind, essentially what is a linear regression? Well, if you go all the way back into very basic algebra, remember the equation y equals mx plus b? Well, at the very basic level, that is going to be a linear regression. Where on the horizontal axis, you have your independent variable, and then on your vertical axis, you have your dependent variable. So essentially, we can have either a positive linear regression or also a negative linear regression based off the data that is going to be presented with it. So at a very basic level, you can take a look at something like years of experience versus salary. As someone has more years of experience within their field, it's expected that someone makes more money and companies will pay you a little bit more. So we're going to be taking a look at that example and coding it out for you guys. Anyways, hope you guys do enjoy this video. I'm going to jump on my Jupyter notebook right now and let's get started coding. A brand new Jupyter notebook over here. Let's start coding. So like always, import pandas as PD, shift and enter. This runs the cell above and creates a brand new one down below. We're also going to throw in a few other libraries. Up first, we're going to do NumPy, import NumPy as NP, right? Then we're going to import Seaborn as SNS, and then also import matplotlib.pyplot as PLT. And lastly, we're going to bring in our linear regression. So from sklearn.linear model, import linear regression. And let me just explain all these real quick. So pandas, this is our data frame. NumPy, we're going to be kind of building out random data from NumPy. So I'll show you how we're going to be using that in a little bit. Seaborn is for graphing as well as matplotlib. Now I have a full video on Seaborn if you want to check that out. Matplotlib not yet. And lastly, we have a linear model, just our linear regression, which we'll be using in this video. Okay, so now we're going to build out our data for the linear regression. And there's a few different ways that you could really do this. I mean, you could download a CSV and bring that up, or even an Excel file. You could just create data over here at the dictionary and turn that into a data frame. I used ChatGTP to randomize some data and make it look linear. So that way this video, you guys can copy the code exactly. So we're going to be using NumPy a little bit. And so we're going to do a random seed. So that way you guys can get the same exact stuff that I have over here. Samples wise, so you can say how many you want, which I'm going to do next. So num samples. I'm going to keep it pretty basic and say 500. I know that's not a lot, but again, this is just the beginning of a linear regression series. So, we're keep it very simple. Next, what we're going to do is I'm doing data based off of salary and years of experience. So we have to build out years of experience. So I'm going to do years of experience over here. We're going to say that's equal to np.random.rand int, okay, and we're going to say it's anywhere from 2 to 21 and size equals, and it's going to be this num samples over here. So we have that. So essentially the years of experience of workers and what salary that they are going to be getting. Okay. Up next, we can define our slope and our intercept. So we'll say slope equals, and I'm going to create a range. So we'll say like 200,000 over here. Essentially, minus 60. And I'm not too sure why there's underscore on these. Again, I just copied this from ChatGTP. So it could work just normally with 200,000 like that. But I just want to copy this because I did test it and the code worked perfectly fine. So I'm just going to copy exactly how it was. And the intercept, we're doing 60,000 like that. And then we're going to do our salaries. So salaries equal, and we're going to take our slope times our years of experience, which is randomized, right? Plus our intercept. So our minimum salary in this case is going to be 60,000. And then we're going to do plus over here, np.random.normal, and 0 through 10,000, which again has this over here. I'm pretty sure it's going to be the same if we get rid of these underscores, but I'm going to test it out another time. And then we have num samples, which is over here, right? And now we can create our data frame from it. So what we can do is data equals, and first we're going to build out a dictionary. So we'll put over here years of experience, and that's going to be equal to this, which we put over here, right? That's going to be our random on that side of things. And then we'll put our salary. So salary, right? And that will be equal to salaries, which we have here. Okay. And lastly, we build out our data frame. So you just do df equals pd.data frame, and you just throw data over here. And I know it's a little bit of coding, which again, feel free to just copy exactly what I did or throw in your own data if you want to, but I just wanted to make it something easy that you guys could replicate one-to-one without even downloading anything. All right, so now we have all this data over here. Let's do a df.describe. So this will just kind of show us some of the different stats based off of this data. So you can see, obviously, our count is 500 for both of these because we defined that as the number of samples, right? Our mean over here is 10 for years of experience, right? We're going for 2 through 20, okay? Minimum is 2, 25% is 575, 50% is 10, right? Max is 20, so exactly what we wanted. And then you can see the salary over here. So the mean is 142,000, as the standard deviation is about 45,000 over here, and their 50% is 139. So, okay, it's pretty cool over here. I want to plot this data before we build out our linear regression just to show you what this looks like. And this is where we're going to be using Seaborn and also a little bit of matplotlib. So let's do that right now. So first what we're going to do, and we're going to just put a plt.figure. Okay, and then you can put fig size. We'll say that's equal to 10 and also 6. Great. Then we're going to do sns.scatterplot. Okay, we're going to say our x equals these years of experience. Years of experience. Our y is going to be salary. Y equals salary. Like that. Data is going to be equal to the data frame, which is df. Okay. And then we can do sns.reg plot. Okay. And same exact thing over here. So we can just copy this, throw that in here. And then we're going to do a few other minor things. We're going to say scatter is false. Scatter equals false. And I'm going to define this color equals red. And I'm going to put over here for this one, color equals blue, just so they're different colors. Equals blue. All right. And we can do our axis labels now. So if we really wanted to, I'll just put them over here for you guys. So we'll do X label, and we'll say that is the years of experience, right? And then we'll do our Y label. I'm just going to copy that and put Y label over here. And that's going to be our salary. If I can just copy that correctly, or I could have just typed it, but kind of lazy. And then we can do our title. So plt.title. And we're going to say regression. We'll just say like linear regression for salary. And lastly, if I coded everything correct, we'll just do a plt.show just to see how this looks. And here we go. All right. So all this was actually generated pretty much from ChatGTP. I just threw in the data over here and said, graph this. And we made a few different small minor modifications over here and built this out, but another use case for that. All right. Now I think it's time to start with our regression. So first thing what we do is when we're going to be working with different models for machine learning, let's split up our X and Y. So first what I'm going to do is our X, and this is a very simple linear regression. So we only have one for X over here. So we're going to do x equals df, and then I'm going to put over here for years of experience, right? And then we're going to say our y equals df, and we're going to throw our salary over here. Okay, so now we have both of those over here. We need to now do our train test split. So let's do that now. And I forgot to import it a little bit earlier. So we'll just import it now. So from sklearn.model selection imports, and we'll do our train test split. And the reason why we're doing train test split is we're going to have some of our data for training purposes and some of our data for testing purposes. I'll show you how to code this really shortly. So all you have to do is xtrain, xtest, ytrain. And I know this does look intimidating if this is your first time building a model, but I can promise you that it gets like ingrained really fast, right? And you feel free to copy it too. You don't have to always code out everything. So test size equals 0.2, which I tend to do 20% for our testing data set, 80% for training. And then you can set a random state. So that way you can replicate this code and you can put whatever number you want. I just put 13. So we have our training, right? X over here, and then they're testing over here, right? So one other thing too, I don't remember if I mentioned it or not. If I did, I'm sorry. When I build out models, I always put a capital X, lowercase y. I see it all across the board when I first started learning machine learning. So make sure you do that as well. It's just kind of standard notation with that side of things. Okay. Now that we have this out of the way, we can start building out our model. So let me build out a few new cells down below and we can get going with that. So I'm just going to say LR equals linear regression, right? Regression. That, and I'm going to put 0 parameters in here. We're going to do more advanced regression videos in the future, but again, just very basic to start off. Okay, now we're going to do lr.fit. So you have to fit your data when you're going to be doing models. So I'm going to put xtrain in here and then also ytrain. And again, that's from over here, our train set, we need to fit. Okay, so now we get this over here that pops up. This is linear regression. So our data is now fitted. And by default, our score is going to be our R2 score. And there's another method of showing an R2 score, which I'll show you in a second. So we can just put over here lr.score, and we can test it a few different methods, right? So we could just do our xtrain and then ytrain and see our score. And we can also do it with our test set if we wanted to. So our train is 0.9519. And if we wanted to do our test set as well, you can just put test over here, right? And we'll put our y test. We have 0.943. So I'll explain R2 in a second. Let's import some metrics over here. So with Scikit-Learn, it's pretty easy to import metrics in. So sklearn.metrics and then import. And first one we're going to do is our mean absolute error. Then we're going to bring our mean squared error. And then lastly, we're going to bring in our R2 score, which is going to be the same as this one above over here, but just want to put that over here. Okay. And then next thing that we're going to do is we have to make predictions on our model. So let me explain how this works. So we have y prediction, right, equals lr.predict x test. Okay. And this might seem a little bit confusing why we're doing predictions, because you would think like, okay, we have our test here. Why are we making another prediction? Essentially, what we're going to be taking a look at is this value of y test and taking a look at how close it is to this y prediction. And it'll determine like how accurate our model is. So our prediction over here is the fit of the data, our model that we think is going to be here, right? We throw in our x test. And again, we're comparing our y test to this y prediction. So essentially, we're going to grab the data from X test. We're going to do the prediction. And what we think it should be is this Y prediction. So that's why we have this code over here. And you do see this a lot in machine learning, Y prediction over here. So something else to ingrain over here. Okay, so the first thing that we're going to do is a mean absolute error, which is this one over here. Now, our mean absolute error is the absolute difference between the predicted values and the actual observed values. So all you have to do for mean absolute error, right, is put first our y test, so this over here, and then you put over here your y prediction. Okay, so just throw both of those over here, y test and our y prediction, and then we get our answer, right? So 7,858. Now we can also take a look at something called the mean squared error. So I'm going to put this over here and I'm going to copy our y test and also our y prediction. Now, what this is the average of the squared differences between the predicted values and the actual values. And you will see like mean absolute error or mean squared error sometimes on Kaggle competitions. This is a way of determining how accurate your model is. So let's put this over here, mean squared error. Let's see our score. So we have a much larger score, which is as expected. Now, our R2 score is the coefficients of determination. So again, it's another way of determining how well our model is. And this specifically looks at the fit of the regression model compared to your data. Now, there's a little bit different way of determining your R2 score rather than just putting your score over here like this, right? So you can just put your R2 score over here like this, and we can throw in our y test and also our y prediction. Right, so throw this in over here, and you'll see we have 0.9432, right? It's the same exact score when we threw in our test data set over here. Personally, I would rather just throw in your R2 score just so it doesn't have any confusion with it rather than just putting your score over here. But definitely wanted to show you guys like the shorthand way of just doing this with your score, or you can just clearly define your R2 score down below. Now, you can also find your exact coefficient and then also your intercept from here. And remember, we have y equals mx plus b. So your b is going to be your intercept, and then your m, which is your slope, is going to be your coefficient associated with it. So let's do that. And it's honestly very, very simple to do. So all you have to put is LR, and then we'll put coefficient like this, and then you put an underscore at the end. And check this out, 7,781. So what that tells us is every single year of experience that someone has with this data set, they go up salary-wise, kind of like on average, about $7,000, let's say $800. And then we're going to put our LR coefficient, or not coefficient, I'm sorry, our intercept over here. And then we'll put underscore here. And this tells us with our model that we have built out that the intercept with 0 years of experience, right, it's about $60,000. So 6161. And if you go up here again, right, just to show you guys, our slope over here is the 200,000 minus 60 divided by 18. And our intercept we defined as 60,000 before we randomized it a little bit. So obviously it's not gonna be perfect, but we're looking really good over here. And I also just want to show you guys really quick how we can plot this coefficient and also our intercept, kind of see how this graph is going to be built out. Again, just use ChatGTP, threw in our data over here, and this is the code that it's spitted out. Super easy way to save some time when you're going to be building out models. So coefficient like this, okay, and we'll put our intercept equals, and I'm just going to copy that instead of that down over here. We're going to do x equals np dot linspace at 0, 20, 100. I'm going to say y equals, and then we're going to say coefficients times x plus our intercept over here. Okay. Then we're going to say plt scatter, throw in our x, which actually I need to make this capital X just for myself. Don't like having it lowercase. X, and then also our y. Let's say label equals f, y equals there. We're going to throw in our coefficients over here. Grab our first coefficient. Then we throw our x in here. And I know this is a little complicated, but don't worry, it's not too bad. It's not the most important thing, but I feel like it does add a little bit of value over here. I'm going to close that out here like this. And then we'll say our color is blue. And hopefully I had no typos. And then we can just label our axes. So plt x label, we'll say like years of experience, right? PLT, which actually I think I'd put those above over here. I can just copy those if I really wanted to. And I think that's what I'm going to do. So we'll just copy this because it's going to be essentially the same. Only thing we need to change, and we're just going to put a plt.grid over here. And assuming that I have no issues, which I do because I have a lowercase x there instead of uppercase. And check this out. So this is the model that we just created, right? So let me explain kind of one more time going through the code, and we'll finish off this video. So essentially what I did first is we imported in a few different libraries, and then we created our random data set over here. Then we described it just to show essentially how our data is, right? 25, 50, 75%, our counts, mean, standard deviation, max. Then we did a very basic plot. We have our scatter plot over here, and then also a regression line based off of this data. And then we set up our X and also our Y. We split X and Y based off of train test split, right? Test size 20%, training set is 80%, which is over here. This decimal represents that. Then we built our linear regression, LR equals linear regression. We fit our data with the training data set. We did a very quick score over here just to see how our R2 is, right? Use your test over here. Then we have some metrics that we imported in, mean absolute error, mean squared error, and then our R2 score. And then we have our results from each of those over here based off of Y test and also our Y prediction, which our Y prediction we created. You predict based off of your X test. Then we got our coefficient and intercept, which is critical for a linear regression. And then we just plotted that over here. And yeah, essentially that is your introduction to a linear regression model. So I hope you guys did find this video helpful and you learned something new about regressions. If you did, make sure to subscribe to the channel. I'm uploading over 3 data science videos every single week. Now, the video is not out yet, but it will be really soon. So if you're watching this in the future, make sure to check this out. But I'm going to have a video on multiple linear regressions. So a little bit more complicated than this one, but I guarantee you that you'll be able to solve these once you watch that video.